Okay, so for today, I'm going to be talking about the concept of metaphors in tech. And the thing is that I find this to be particularly valuable. Now, the reason for that is I think of them more as mental bookmarks, and this becomes very important because once you're familiar with it, it's fine, you don't need this. But before you get there, having this set of metaphors might be very useful for you. So maybe let me kind of start. So I see them in terms of different ways, and of course this is not a complete list, but one of the first ones we can start with is what you'd normally see in terms of like an architecture. So whenever you're talking about an architecture, you want to think, okay, maybe from the concept of a house. So if you think about it from the concept of a house, then you have multiple things to work with. You can talk about maybe what does the foundation look like? What does the door there mean? What does a window there mean? And you can also start thinking about it from a different perspective. So if there was going to be plumbing in that in that house, how would that look like? So then you'd think, okay, going through the house, maybe something like data flow, right? Maybe here you'd think about what are the design principles, right? And then here you can think about how does the data flow look like, and that might be a good way for you to start. So it gives you access to other items you can maybe start thinking about. Maybe you can think about, all right, how would a blueprint here look like? So if you are designing a house and you had this big item, and you understood that before you get there, you need some kind of a blueprint. So then ask yourself, okay, what's the detailed plan or the specification? And that might be a kind of a good place to start. Okay, so continuing on, maybe you might want to think about other metaphors that would help you. Maybe let's think about code structure now. So there are other ways to look at this, and this one particularly maybe it's close to my heart because I know this is where we all start. And someone might talk about, for some reason here, maybe a lot of the metaphors are going to be related to what you'd find in Italian food. So that's a fun part, right? And as you can guess, this is what you'd start by calling spaghetti code, right? So this is just code that kind of goes everywhere. It's pure. It's very poorly structured. It's very hard to maintain, and this is really a problem because if you think about the main axis of any application that you're writing, is the first thing is that it must be maintainable, and part of being maintainable is someone must be able to easily understand it, and it must be able to be operated, and preferably by someone else. So if you have spaghetti code, that just doesn't work. Now, I don't think many engineers stay here for a long time. Unfortunately, they tend to go towards another kind of architecture, which you're going to call ravioli. So you know what ravioli is? It's basically another type of pasta, but looks a bit like small pockets. We'd normally call them samosa, but I don't know how popular that would be. Maybe I should call it samosa because I'm more familiar with that terminology. So maybe this kind of code is where you get to the situation where everything is isolated, and there is no way for communication to happen unless you start doing all these crazy things. And this is where I normally find people who start from the offset thinking about microservices. You almost are certainly going to end up here where you have there's really no easy way for items to communicate. You need to set up some kind of interchange even for the smallest problem, and that I think can very quickly become an issue. You might wonder then what good code looks like. You might want to think about it maybe as what a lasagna would look like. So lasagna is made up of these nice layers of you find some kind of pasta on top, then maybe there's filling here, maybe there's some meat or something, and then again another layer, maybe cheese or something like that, and then more filling and things like that. So that means that there's really almost a clear modular architecture where you can actually see, okay, so this talks to a layer just down below it, and so on and so forth. So this is what we basically want to aim at, where there is separation, where the separation is also appropriate for the complexity of the problem. So for example, if you look at this particular situation, it's very easy to introduce accidental complexity, which is where the system itself is more complex than the problem that it's trying to solve. All right, so it doesn't matter who you are. The moment you have created a system, the next thing you're going to have to deal with is this guy, debugging. So someone once said that, a senior engineer is just a really good Googler. I think that's really true. So some of the way that I think about this is think about it like a Sherlock Holmes, right? So there are a lot of items. You don't know what you need to do in order to get to this particular problem. How do you identify the particular problem, right? Something else to think about is, if you have a haystack, how do you find that particular needle, right? So how do you find that needle inside a big haystack? So that might be good ways to think about it. The Sherlock Holmes is because we say, okay, let's find a way of systematically eliminating possibilities until we get to what is the main problem. It's also sometimes called RCA, more formally, or root cause analysis. Something else to think about is, it might sound ideal to think about this problem as non-moving. That's rarely the case. Most bugs worth any mention tend to be very complex. So that means you're going to be in this situation where maybe you are chasing after some kind of, I don't know, some kind of thing that has, that is kind of running, okay, clearly this is where my drawing skills end. But you're kind of trying to chase some kind of really fast creature, so think like a rabbit, for example. So you're really trying to go and chase out that rabbit. Now that means it's not stagnant, it's moving, and that also means you need to be in however you're setting up your code, when you're doing instrumentation, you need to think through, if I have bugs that appear and disappear during certain points in time, how would I be able to capture that? Maybe using something like a rolling window, or doing like some kind of random capture, because getting all the input and output of a system might be a bit much. But maybe if you set up the right kind of random windows, that bug might be caught within that particular trap. So you need to always think through ahead. We also have to think about like Pandora's box. So sometimes if you're looking at, especially like really old code, legacy code, and when I say legacy code, maybe it's not based on time, it's based if that thing has tests. So if you're working through code that has no test, that just works, perhaps it's just better to let it be. And that's because you don't know all the amount of hell that's going to come if you try to change that. This is what sometimes you look at called maybe like a cascading problem, where you find once one domino falls, many dominoes start falling, and just kind of following that. So that's something to give some thought about when you're going on that trajectory. All right, maybe let's think about some other places that are interesting. Maybe let's talk a bit about performance. This is always an interesting topic. When I think about performance, maybe a good place to start with would be how you'd look at things like latency, right? So normally, if you think about the performance of a system, you can usually get things like average response time, but that typically means nothing. So if you look at average, and by average I mean a mean, this is normally a problem, because you might find situations where the very few requests are either pushing the mean up or pushing the mean down, or even worse, they're just having no effect on the mean. Now this is usually going to affect your topmost client, and they're the ones who are going to suffer the most. So if you have this situation where everyone here is doing well, so they're kind of okay, this guy, however, he's full of failures, right? This is a problem, especially because this is probably your most valuable customer. Imagine something like Google Drive. The person who has the highest amount of files stored is probably paying the most, right? Because you're maybe charging by the tire they are in, and you really don't want to kind of piss them off. So this is, if you were to imagine this as a long animal, this will be the tail of it, and that's what we normally call tail latency. Latency is just the amount of time that you spend waiting for something. Another way to look at it is whether there are better ways of, maybe improving the performance. And here is where you start thinking about concepts like overheating. So if you get to a point where, or maybe a better word for it will be turbocharging. So turbocharging is where you maybe pump extra oxygen into kind of your vehicle, and that makes it go a bit faster, really. But this usually comes at a really high cost, right? So your vehicle is going to get, you're very quickly going to start losing performance, or maintaining that vehicle becomes harder and harder, right? So the other ways to think about it, you call it turbocharging, or even like squeezing the orange, and really that's why you're going too far. On performance, I think scaling also comes in here. Now, usually when you think about scaling these days, it's more or less bringing a situation where, as requests are coming in, they are usually coming in to one server. As more requests come in, another server or another machine is automatically created. So in these kinds of scenarios where we have no human operator doing this, you can think about the whole thing as some kind of stretchy rubber band that stretches up and down according to the current according to the requirements. So this is where you'd call maybe the system something like elastic. That's an elastic system. Of course, there are other concepts that are related to elasticity. So for example, you might want to, if you have a large database, and okay, this one cannot fit into our normal buckets, then maybe you want to shard that. So you have smaller buckets, and then you have your data sitting in all these smaller buckets, and then it fits. So basically, you have decided to shard that, and that might be also somewhat like another useful analogy here. I guess this next one I'm thinking also might be a lot about the data itself. So one of the things when you think about data, because data is something that flows, and I think we did have touch a bit about that, how that might look like. Maybe you have multiple tabs or things like that. So the idea is data does flow. So you might think, okay, so if I had a large data, how would that look like? You say, oh yeah, if I had a large data, then I'd call that like a data lake, and then I'd say maybe data streams into the data lake, right? So I think that's some interesting analogies to use there. So you'd call something like a data lake, you'd call something else like maybe stream processing, and that's a useful way to think about the data that you kind of have coming in. I've never had someone say data ocean. I've had data warehouse, but I think the idea kind of remains. So things that have flow, you can say that the data is blocked somewhere, or maybe you have back pressure happening, or maybe you have things like I was talking about the processing part now. Talk about things like head of line blocking and such. So gives you some ways to think about that. I don't think all of this would be done, especially because I am, at the end of the day, an engineering manager. All this wouldn't be done if we couldn't talk about the human aspect of it and the individuals working on this particular item. So probably the Easiest way to think about it is if you had multiple people on a boat and you want them to all row in the same direction, right? This is where the ideas of things like sailing come in, and you can use that, right? Or you can say, for example, we are agile, and we have someone maybe has like a finger in the air, and that helps them to get a sense of where they're trying to go. Maybe we can talk about where the sails are, reading the wind or changing the sail, and that means continuously adapting. So one way to think about it. Something else I'd also say maybe is maybe something like analogy of like gardening, right? So this is where you think about it more from like nurture and growth. Okay, so usually when you're thinking about people, you can't build people, right? You can't bring component A and B and just like that happens. Growth comes internally, it's not imposed externally, in the same way that you can build a building by bringing materials from the outside and combining them in a certain way and ending up with a complete building. You can't do that with people. Basically, that's natural. Growth comes from within. It's like a plant that just its growth is not imposed on it. It comes from within itself. Now, of course, it consumes resources to get there, but that's different. So that might be another way to look at it, as gardening and nurturing and growth. Yeah, so that was some of the ideas I had in terms of thinking through analogies that hopefully help cement some of these concepts in your mind, or at least act as bookmarks. I'm happy to hear about any other ideas that maybe other people have on the analogies they use on their day-to-day. Thank you.